In this video, we'll be talking about graphing different types of functions. In this video, we'll be talking about graphing different types of functions. So a graph is a pictorial representation of a function. It visually shows you intercepts when the function increases or decreases, among other things. So when we look at this example here, we have y equals to 5x minus 2. So this is actually a linear function. What we know about linear functions is that we can actually plug in any x value and we will get a singular y output. So let's plug in values, let's say when x is equal to 0. Put in this table here. So when you plug in 0, 5 times 0 is 0, minus 2 gives us y equals negative 2. Let's say when x is 1. 1 times 5, or 5 times 1 is 5, minus 2 gives us 3. Let's say when x is negative 1. 5 times negative 1 is negative 5, minus 2 gives us negative 7. And finally, let's say when x is 2. 5 times 2 gives us 10, minus 2 gives us 8. So these are points that we can graph and then connect them to get our linear function, which looks like so. So the 4 points on there are the 4 points that we just put that's on our table right there on the left. So when talking about graphing functions, the first thing we need to understand is how to graph the parent functions. So these are the most common parent functions that you might see in mathematics, and it would be good to familiarize yourself with these parent functions. So when graphing parent functions, we first need to know what the parent function looks like, and then we plug values of x into our function to get a corresponding y value and plot it on our graph and then draw our graph. So for the parent function of the quadratic function, f of x equals x squared, it has what's called a parabola shape. It has kind of like a U shape here. So if you want to graph it by hand, what you do first is you start plugging in values of x. So let's say we let x be negative 1, 0, 1, and 2. So then we take those values of x, we plug it into our function. So negative 1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. So if we plot that on our graph here, that's how we would do that. So we've put negative 1, 1, that's right here, that green dot, 0, 0, right here at the origin, 1, 1 is the blue dot, and then 2, 4, even though it's not stated, it's somewhere around right here. So if you connect your lines, or connect your dots, that's how you get the parabolic shape. So sometimes there would be what's called transformations that happen to certain functions. How you would describe it, it depends on what the transformation is. The different types of transformations are reflections, and that would be across the x-axis or y-axis. There's a horizontal or vertical stretch, and there's a horizontal or vertical shift. Now, for this particular example here, f of x equals x minus 2 squared, notice the minus 2. That minus 2 on the inside of the parentheses basically represents a horizontal shift, and horizontal being either going left or right, and the sign is actually important in determining if it goes left or right or not. So for horizontal shift, the sign is always opposite what direction it's going. So if it's saying minus 2, it's actually going to the right 2. So looking at this graph here, the red dotted line is your parent function of just f of x equals to x squared. And then that x minus 2 squared is that blue graph. The blue, what's called a parabola for quadratic equations. So it's being shifted to the right too. So it's taking the vertex here and just moving it, the graph, translating it 2 units to the right. And that would be the graph of your function. For this example, we have f of x equals x plus 1 squared minus 3. So just like the last question, because that plus 1 is on the inside with the x, it's considered a horizontal shift. And because it's plus 1, it's actually going to the left 1. So horizontal shift here is left 1. Now vertical shift is that minus 3, because if you have some value on the outside of the x, it's considered a vertical shift. And because it's saying minus 3, it's actually going down 3. So starting from the origin, or what's called the vertex of the parabola, this is where you start, and we end up moving left 1 and down 3. And that's where we get that point right there. And then basically it's shifting to left 1 and down 3. That's the blue graph. That's the graph of x plus 1 squared minus 3. For this example, f of x equals negative x squared plus 3. We have a new type of transformation we haven't seen yet so far, is that negative. So because that negative is technically on the outside of the x, it's a reflection, but to be exact, it's actually a reflection across the x-axis because it's considered the outside. And keep in mind, technically, as because a parabola is symmetrical, it's like mirrored, there is no reflection across the y-axis, because if you reflect across the y-axis, it would technically be the same image. So this would be a reflection across the x-axis. So basically what it does is it flips it down. It flips it over the x-axis. And then the plus 3, again, is a vertical shift. So it is a moving up 3. So that means that what we do is you take from your origin, you go up 3 units. That's where your vertex would be. And then we pick two numbers on the left and right. So let's say we pick -1 and +1 and plug it in. Now you want to be careful when you're plugging it in this time. And when you plug in x equals -1. So you'd have -1 squared plus 3. So following order of operations, you would square the -1 first, gives you a +1, then you apply a negative to it, gets you a negative again. So -1 plus 3 is +2. So that means that when this is 3 here, you would have, when x is -1, y is 2. Same thing when you have x is equal to 1. You have -1 squared plus 3, which gives you -1 plus 3, which gives you 2 again. So this time what's happening is your parabola is pointing downward, like so, as opposed to upward on the parent function. For this example, we have f of x equals to 1/4 x squared minus 4. Now this right here would actually be a vertical compression. And the reason why it's a compression and not a stretch is because the a value, the value in front of the x squared, is less than 1. So if it's a, if you have a x minus h squared plus k, let's say that's our standard form for our function, or of a quadratic, the a value, if the a is less than 1, it's considered a compression. And because the a is on the outside, it's considered a vertical compression. So our a value here would be 1/4. So what that basically does is that if you look at the blue graph compared to the red graph is the default parent function, f of x equals x squared. The blue one, it's a little bit wider. That a value makes it wider as compared to the parent function. And then as before, that -4 in the outside right there, that's a vertical shift. So it's moving it down 4. So it's being, the vertex in this case would be being moved down 4 units, and also it's being compressed, so it makes it a little bit wider as with that 1/4. So when looking at a cubic function, the parent function f of x equals x cubed has the shape of this, where it is dipping down on the left and kind of curving upward on the right side. Now, the rules for transformations will still apply the exact same way with the cubic function as it did with the quadratic function, which we will see in a minute. So this is the graph of f of x equals x minus 2 cubed. The red dotted line represents the parent function, and then the blue line would be the function of this example here. So if you see that x minus 2 to the power of 3 raised to the power of 3, that minus 2, just like before, is considered a horizontal shift. So all this does is it moves it to the right 3. So it's moving, right 2. So all it does is it shifts the whole graph to the right 2 as seen on that blue graph right there. So the same rules of transformation that apply to the quadratic will apply to the cubic as well. Same as it goes for this function. F of x equals x plus 1 cubed minus 3. Now, you kind of want to notice here that on our parent function, on that red one, that red dotted line, there's kind of that little flat portion at the point 0, 0 right here. You kind of want to treat that as what's like your anchor point. So that's what the point that you want to focus on that's being shifted or in whatever direction it is. So for this question here, we have the x plus 1 on the inside. That's a horizontal shift. So that's actually moving left 1. And that minus 3 is shifting it down 3. So from this anchor point here, we notice that it's moving left 1 and down 3. So the 1 would be right here and it'll be down 3, which is right there. And that's where that new point is being shifted and along with the whole graph. So that blue line, the blue curve is our new function, our transformed function. For this function here, we have f of x equals negative x cubed plus 3. So the S4 plus 3 is a vertical shift. So we know that it is moving up 3. So treat this as your anchor is being moved up 3 units. This is where 3 is. But one thing to consider is that negative in front of the x cubed, that's a reflection. So what reflection would be? It would actually be a reflection across the x-axis because it's considered on the outside. So it's across the x-axis. So when you're flipping it, instead of coming on the left pointing downward and on the right pointing upward, it's now on the left it's pointing upward and on the right it's pointing downward. And that would be the blue curve right there, which represents negative x cubed plus 3. Now we have f of x equals 1/4 x cubed plus 4. So the plus 4 is considered a vertical shift. It's moving the graph up 4 units. And then, so our anchor point goes from down here to from the origin up to 4. And also, now the 1/4 is, again, just like the quadratic we mentioned earlier, it's considered a vertical compression. And the reason is because the a value is less than 1. So our a here is 1/4. And basically the compression makes, if you notice the graph here, the blue curve, it's a little bit wider as opposed to the red curve. Specifically, if you look at this portion here compared to this one. So the 1/4, that vertical compression, widens the curve on the left and right of the anchor point, so to say. Just as mentioned in the quadratic and cubic functions, the parent function, the absolute value, has the shape of a V, kind of V-like shape. And absolute value is always a function that has the 2 bars around the x, and that's absolute value. So the same rules of transformation can be applied to the absolute value function. So for f of x equals to absolute value of x minus 2, because that -2 is inside of the absolute value along with the x, it's considered a horizontal shift, and all it does is it shifts the graph 2 units to the right. So you think of this as right 2. So as before, the anchor point, so to say, on the red line here, which is the parent function, is being moved 2 units to the right. So the shape still stays the same, but just being shifted over to the right too. For the function f of x equals the absolute value of x plus 5 minus 1, we have 2 transformations going on here, that plus 5 and the minus 1 on the outside. So the plus 5 on the inside is considered a horizontal shift, and it's being shifted 5 units to the left. And then the minus 1 is a vertical shift, and is moving down 1. So from the anchor point here, it's moving left 5 and down 1. So now it shows up right here. And all it does is it shifts the graph 5 units to the left and 1 unit down, as shown on the graph here. For the function f of x equals negative absolute value of x plus 6 plus 3, there are 3 transformations. The negative on the outside, the plus 6 on the inside, and then the plus 3 at the end right there. So first off, the negative on the outside is considered a reflection, and it's a reflection across the x-axis. So it flips it basically pointing upward to pointing downward. The plus 6 on the inside is a horizontal shift, so it's being moved 6 units to the left. And then the plus 3 at the end is considered a vertical shift. It's moving up 3. So from this here focus here, it's moving left 6, up 3, but then it's also being flipped over. So from pointing upward, now it's pointing downward, and as shown on the blue curve here. Now there's a square root function as well. So the parent function of the square root function looks like this. You can kind of think of it as a parabola or an x squared function, a quadratic function that's kind of fallen down to the right side, but you're only taking the positive part, because as mentioned before, when you're taking the square root of something, the square root, you can only take square roots of positive x values. You can't take square roots of negatives. That's why it's only the positive part of it. So when you have f of x equals square root of x minus 2, that minus 2 is inside of the square root, along with the x. So because it's on the inside, it's considered a horizontal shift, and it's moving 2 units to the right. And so if we look at the red dotted line is our parent function, the blue one is square root of x minus 2. It's being shifted 2 to the right. For f of x equals square root of x plus 1 minus 4, there's 2 transformations going on. The plus 1 on the inside of the root and the minus 4 on the outside. So on our parent function here, this is where kind of the starting point at 0, 0. So what that plus 1 does on the inside is a horizontal shift. So it's being shifted left 1, and the minus 4 is being shifted down 4. So that 0, 0 is just like before, it's considered, let's call it your anchor point. It's not a formal way to do it, but it's a good way to kind of see of how your graph's being shifted. So that anchor point is being shifted left 1 and down 4. So now the anchor point is now starting down here, and then the whole graph, the shape of the graph still stays the same. So it's being drawn to the right and kind of curving to the right. So that is that blue graph there. And that graph is f of x equals the square root of x plus 1 minus 4. So as noticed before, this transformation still applies to the square root functions. Now we have f of x equals to negative square root of x minus 5. So again, there are two transformations going on here. That negative on the outside is a reflection across the x-axis because it's on the outside. And then the minus 5 on the inside, the square root, is a horizontal shift. It's being moved right 5. So this anchor point is being moved to right 5 units, and it ends up right here. And then because it's a reflection across the x-axis, it's kind of curving instead of upwards to the right, it's curving downward to the right. So it's being flipped down over across this x-axis here. So finally we have f of x equals the square root of 2x. So the 2 this time is on the inside of the square root, and the x is being multiplied by the 2. So this time is actually a horizontal compression. The reason why it's horizontal is because it's on the inside of the square root. So this time let's call it the a value would be 2 in this case. So all it does horizontally is that, just like before, it makes the graph wider. So if you look at the graph on the parent function, the red dotted line, as opposed to the blue line, the square root of 2x, it's opening up a little bit more. It's a little bit higher up. And that's basically, think of it as being widened. It's further away from the x-axis as opposed to the red line. So if you notice throughout this video, no matter what type of function you have, whether it be quadratic, cubic, absolute value, or square root, the rules for transformation can be applied to all of them. So it's best to know your parent function and understand what the transformations are, what's happening in the function, to identify what type of transformations that they are.